Hello everyone, so today I will show you how to using this Keyence laser microscope to measure our MEM device. So first we need to turn on this computer and this computer. This one will operate this microscope, and this one we will use our software called VKBC to take the image and profile measurement. So when you press on VKBC software, there will be a warning saying that they cannot find the GAJ disk, but we can ignore this error. Click OK, and here's the interface of our software. Now we're not gonna work on this right now, so we're gonna move to our microscope. So by using this KVM trick, we can trick the output. We can trick the output VGA screen from the microscope and the PC. So now we're gonna change this button to change to our microscope screen. So now we got here. This is everything under the 20 time lens we are currently using on our microscope. We have various lens here, such as 100 time lens, 10 time right here. This is 50 time, and in this tutorial we refer to use the 20 time microscope lens. So you might notice this not here. It used to operate the direction of the table. So this will give us the X direction. And this one will give us the Y direction. And this big knot right here, these two big knot will use to operate the focus of the image by adjusting the lens position. So you might adjust this one, and you might see the focus is changed to the substrate below. And if we turn on this way, it will focus on everything on our device, including the parts and the substrate and the anchor. Okay. Now we're gonna work on the laser measurement. So first we press on this button to turn on the laser mode. You will see there will be a thin light of laser scanning on our device, and this button right here we use to turn on and off the laser shutter. Turning on this direction which means it will off, the shutter will close and we cannot see our laser on the device. You see right here, even though the laser mode are still on, but there's no light, there's no laser light scanning on the device. Now we're going to turn it on again. So the purpose of this step is to adjusting the lens position, to adjusting the focus of the laser beam. We want it to be a focus as possible to our device. So this way it's too much, but somewhere around here is good. And we're gonna change the laser beam focus to the object we want to take the measurements. In this tutorial we will try to measure the height of the pad with the substrate. So the object will be the pad, the electric pad. Okay, we might gonna turn this one off. You can see right here, run mode. There will be a lot of mode for us to select. But first we will try to calibrate lens position and other parameter in this black white mode. And this pitch right here is it's like enrichment step, but we will talk about it later. So since we have our desired position, we will reset this value to 0 and go into store to try to calibrate our value. So based on the manual, first we need to turn up the laser shutter. And this is what appears when you turn up the laser shutter. Now you want to try to calibrate the laser offset to achieve the correct saturation value. The value recommended by the manual is where around 30. You can use the up and down button to change the value. Okay, so this is quite good. So we're gonna keep this value, this saturation value. Now this will affect how our picture quality is captured. So since we are working on the laser up, now we want to turn it on back again. So you're gonna barely see the everything, the geometries of the device. And what we're gonna do now is to operate the lens position to capture the high and low value, which will be our distance measurements. So I'm gonna change it right here. I'm gonna take the high first. Based on the manual, it's recommended to take somewhere around 30 to 40, but it depends on your experiment and on your chip layout, because it will affect the time of the measurement. So if you set it too much, like high 30 and low 30, the combined distance will be somewhere 60 micrometer, and the time consuming for the measurement would be 2 minutes 20 seconds. Although it will also depend on the pitch value I mentioned before, but it would be a time consuming, so you don't want to take that high distance. But in this tutorial I will demonstrate how to follow the traditional manual. So we have the target value right here, we set to high. Now we control the low by hold the down button until we reach our desired value. Okay, now we set it to low. You will see the combination of high and low would somewhere around 60. Since this monitor resolution is not compatible with this machine, so there should be some cut off right here. We cannot see fully the detailed information, but we can got enough for us to work around. Now we're gonna have all the value. You can see the distance right here and the time consuming. We're gonna return. And as I mentioned earlier, this pitch value will affect how we take our measurement per increment. So for example, the distance is 62, so if we change to 0.1, the time consuming would be lower, because it try time faster than using 0.05. So I'm gonna use 0.1 in this tutorial, and we're gonna change back into the color SPD mode to do our measurements. So we're gonna press here to start. Okay, now since we have every parameter calibrated, so we just need to do the measurement right here. There would be a stop button somewhere somewhere here, but we cannot see it clearly, but we can guess it's there by hover our mouse, hover our cursors on the right side of the screen until there are some pop-up appear. Yeah, so you can click it to start your measurements, and you can see that the total time approximate is somewhere around 1 minute and 54 seconds. Last time we see it somewhere 2 minutes and 20 seconds, right? So the time measurement is decreased. So we can go ahead to start our measurement by click here. Mình chỉ hề ngứa miệng quá. It will take time, so we can wait for a while. See, the laser is scanning from the high area to the low areas we said before. You can see the changing slowly happening. See, now it begins to do the measurements. It will take 1 minute 50 something seconds. Right now you don't want to touch anything. You don't want to change the. You want to touch on this computer and on this machine, and you don't want to press anything on your mouse because it's showing right here. Right click to stop. Which means if you right click right now, you have to do it all over again. And if you make any change on the microscope right now, the image would be a mess because it's not correct anymore. Okay, now since we finished our measurements, can have a 3D profile. In case you need it, you can go to this screen mode 80 to see your 3D profile. This is your light sensitive picture, which we will use to do our measurement later in the VK-BC software. But here you can see your 3D profile by trying to hide screen 80 screen 80 SCRN and press 3D. So this is your profile. This is the W mode, and you can change to solid. Okay. Now we're gonna go back to our previous menu. There would be some exit button somewhere on the right corner of the screen. But since I mentioned earlier that resolution of the monitor is not matched with the Keyence machine, so we need to give it a look by hover your mouse, your cursor somewhere here, and try to click. Okay, now you escape it because there would be some escape button right there, and we cannot see it. We're gonna go into display to save our image and walk around on VK-BC software to take the measurements. So we have COND and IMG, which stand for image. There will be three slots. Right now our measurement is saved in slot 1, so we press on 1 and press save. Remember to choose this color grow LT screen, XT screen instead of this one. This one only it check the color, so better use this one. Okay. Okay, now we're gonna change back to our computer to do the measurements. Press on this button. So in this software we will check our data from the save slot 1. You can name it everything. Remember to name your file before we make any further step. You can name any title you want. Now you're gonna use this profile mutable to do mutable profile measurement and change to this light screen, or you can change in this. There will be 3 modes for you: the color, the light intensity, and the high display. So press on this one. press on this profile multiple to do multiple profile. They will give you 3 profiles for your measurements. So we press here. Sometimes if you open this one and you accidentally press close, you can turn back by using this one. For example, if I do a measurement like this, there will be a result here, and I make some segment. But if I accidentally press close here and I want to go back on my dialog, if I press on profile multiple, it will erase all my segment. So you don't want that to happen. So remember, when you press close, better to go back on this one, measurement dialog. See, if I close this one, I could go back on measurement dialog and to keep all my segment, all my measurement segment. So we have we can clear our profile, which means clear everything here, clear every data in profile 1, or you can try to clear your segment. To clear every segment marked on your profile, or I can just click clear. We have many measurement line, free line, horizontal line, and vertical line, or you can specify a length for it, but right now I prefer to use free line. So you track a line along your anchor, your measurement object. So we see this is the safe, the height, the depth of your anchor to your reference surface, which is the substrate, which is the and you might see that the vertical range is quite higher, so we can change here to make it more visible. Maybe I can just 6 or 8 or maybe 10. Okay, you can see there will be some noise here. Because the laser beam is not accurate, so there will be some noise. It's okay, we just focus on our measurements. You can go on 200 scale to see it more clearly. So this is the 1A and 1B represent for the first point to the last point. The total length of the segment 1A and 1B would be 217. Okay, so now we want to check our measurement. You may ask how to calibrate. Since we have to surface, to pass surface, gonna take some reference height of it. Here, this one. Take the first segment, second segment, and remember to calibrate them to 0.01, because there will be some noise, so we set it back to 0.01 to make sure this is a flat surface. Finish. Now you will see that it become flat because we have scaled down everything to 8 times. Right, see that our last value is somewhere 0.08, but now we set it back to 0.01, so everything is scaled down 8 times. So you might want to change your vertical range to see it more clearly. Make it 2, okay, or even 1. Yeah. So now we're gonna measure our height between the path surface and the reference surface. So you take one segment here and track your mouse to every point you want to take a measurement. For example, I set it this way. So you see the first point and the second point. From the first point and the second point, you will see three value represent for the distance from first point to second point, and the height difference between them, the height difference of the point 1 to the second point, and angle between them, the angle difference between them. After that, you can export your measurement as an image. You can try to name it to anything you like. Save. There are many types of save you can choose, but I prefer to choose the PMP because it captures the high resolution for you, and it's easy to do post processing on Illustrator later. Save. This will be this one. So you have this here. Okay, that's all for the tutorial today. Thank you.